Okay, we have a pay rate function, this, okay? And we want to get the pay from t equals 0 to t equals tau. Now let's just think of what a trapezoidal approximation graph of this function would be. Now this is clearly a quadratic function. It's going to be increasing for t greater than 0, and it's going to then be an upward opening parabola because you have a positive constant in front of t squared. So we're going to have a pay rate that starts at 5,000 and goes up, okay? Now let's first of all think about what a trapezoidal approximation graph for this thing would tell us, okay? So let's just say we have two trapezoids here. We could have more. But for a given trapezoid, what's the average altitude? It's the average pay rate, and that's going to be in dollars per month, right? With is your time interval. Altitudes of pay rates a run is your time interval. Okay? So area is average rate times your interval. That is your average pay rate in dollars per unit of time multiplied by the time interval in units of time. Okay? Now this is approximate average because obviously when you do a trapezoid you're cutting across the curve. So the average on this line is a little higher than the actual average value under the curve. And we'll say a lot more about that later. So this is the approximate average rate. But anyhow, this is the approximate then pay during the interval. And areas correspond to integrals, right? So slopes, well, you can interpret the slope. It's the rate at which your rate of pay changes. Okay? It tells you how quickly your salary is going up. Okay? So this would be the pay for this interval, this would be the pay for this interval. And of course this corresponds to area by our notational convention, circle. Okay? You would have total pay here through the end of the interval. I don't have room to write that all out, but we know what that means. And this would be your next total pay. So this would be your total pay through here. This would be your total pay through here. Well, if, of course, this is t equals 0, if tau is here, then you'd have the total pay through the end of this interval, right? And if tau was here, that would be the total pay for this interval. So total pay from t equals 0 to t equals tau is what? It's the area under the graph from t equals 0 to t equals tau. And that's an easy connection to make if you understand the interpretation of the trapezoids.
I'll be right back. I need to talk to you.
And that is the integral from 0 to t of your pay rate function. Okay? Now, if you've worked through the details with the units on the trapezoid, you see that, when I wrote this down, I wrote it down incorrectly. That's month cubed, and that is what it says in your paper. Because I wrote down month squared there and then realized that was wrong. And then I wrote it down wrong again. Okay, anyhow, if you multiply this by a t squared in months, you're going to get $30 times whatever the magnitude of t squared is, the numerical value, per month, right? Because this will have a squared month, this has a cubed month, right? You're going to end up with pay per month. And you're going to add that to pay per month. Okay? When you integrate that, well, you're multiplying pay per month by time interval, which is in months, and you're going to end up with pay. So we want to understand that in all possible ways. Then suppressing the units, if I understand that, I'm safe in just saying, okay, I'm just going to look at the numbers. 5,000 plus 30t squared dt. And I said we're integrating from 0 to t. We're integrating, the interval goes from t equals 0 to t equals tau, right? So we're going to put tau here. And that's a really easy integral that you can probably do in your head about as easily as I can, except I'll probably mess it up and you wouldn't. Okay, so we got 5,000 tau plus 10 tau cubed. Okay? Now I would then evaluate this for the 2 trapezoid model, or for the 1 trapezoid model, or for the other model. Well, actually, and let tau equal. I mean, it's a 10-month period. If you let tau equal 10, you should get the accumulated area for each of the 3 graphs that you've done. Because the context of this problem is, okay, approximate this for 1 trapezoid, approximate it for 2, then approximate it for 5. Okay? Calculation's going to be easy. This is an easy function to evaluate, so it's just going to be simple numbers. It shouldn't take you 5 minutes to do the calculations. Well, then you could put 10 months in and see how that compares with the total pay through the end of the 10th month, right? And that would be a good check. If it isn't pretty close on the 5 trapezoid model, which is going to, as you will see, stay pretty close to the actual curve, then you know you messed something up and you go back and fix it. Because there's nothing here you don't know how to do.